About two-way ANOVA with replication. We have studied about one-way ANOVA. We have also seen about two-way ANOVA without replication. And here today we are going to see two-way ANOVA with replication. In this case, why is it two-way? It's two-way because we have two factors, and our factor is watering frequency, and the other factor is fertilizer, and our dependent variable is fruit weight. So we want to see what is the influence of either water frequency on fruit weight, or what fertilizer type on fruit weight, or both watering frequency and fertilizer type on fruit weight. So for us to do this analysis, remember what we had said earlier, Excel does not understand data when it is in this form. So what you need to do, you need to rearrange this data, and this is how we have arranged our data. So we have put our fertilizer in the columns, and then our watering frequency in the rows. So all data associated with watering at once per week, that is for nitrogen, calcium, phosphorus, potassium, and no fertilizer, has been all of it is within this level. And why is it with replication? You'll find that in nitrogen there were three collections. That is, we have this collection, this collection, this collection, and this happens in all of them. Like for once a week, three collections. Once a week for calcium, three collections. You can say potassium and thrice, three collections. So you'll see it has been replicated thrice. So for each and every factor has been replicated three times. So for us to analyze this data, remember, come here to the data toolpack. You come to the Excel toolpack here, and then you choose data. In our far right hand corner at the top, you'll find data analysis. If not installed this, we are going to I'm going to share a link on our previous videos on how to install data analysis toolpack. So click data analysis toolpack. Among these tools that we have here, we're interested with the replication, two-way factor with the replication. So select two-way factor with the replication and click OK. So once you've clicked OK, then you go to input range. In the input range, we select all the data sets here. Once you select all the data sets here, and then the other question comes here is rows per sample. So how many rows per sample? In other words, we are asking what is the replication? How many times has the data been replicated? You'll see that per sample, so the first sample here we have is once per week across all these fertilizer level. How many is it? How many are they? It is 1, 2, 3, 1, 2, 3, 1, 2. So you put here 3. And then output options, of course, let us select the way in a new worksheet apply. So we still want our output to be in the same worksheet, but in a different, in the same workbook, but in a different worksheet. So click OK. So great, now we have our results here. So once we have our results here, you'll find that average, let's say once a week, we can get the average levels. So the average levels will find that nitrogen fertilizer recorded the highest at once a week watering frequency, followed by the no fertilizer. So you can get all the summaries of each and every, let's say it's daily. You'll find that in daily, that is 25. This is the highest average at calcium. So calcium recorded the highest. When you're applying calcium, you'll get the highest, and when you're putting water on a daily. So if you're not watering, the highest level will be 18.8, which is potassium. So that is how we are going to get the results. So, but now our general results, these are our general results. So we need to have a level, a reference level, that is our significance. %, which is 0.05. So when it is there, so and then we need to change this sample. Remember our sample. Our sample was what? If you come back to our data here, this was our sample. So it is watering frequency. This is watering frequency. Columns, fertilizer. These are the columns. So change again here. Columns, you put fertilizer type. And then that is the interaction. You can just let it really understand that is the interaction between watering frequency and fertilizer type. So let us go to our p-value. Our p-value is where makes sense to us. So the first thing is watering. You get it is 1.342 E negative 13. E means 10. So if it is 10, if it is 10 power, 10 power what? Power negative 13. That is 10 power negative. So that means it is 0.00000 all the way to 13 decimal points. So if it is all the way to 13 decimal points, so this tells us that definitely this is less than 0.05. And remember our thumb rule. If the p-value is less than the significance level, then we reject the null hypothesis. And what is our null hypothesis? Watering frequency has no influence on fruit weight, or there was no significant difference in the fruit weight across all the watering frequency. So we go to the next one again, 0.006, which is still less than our significance level. So again, we reject the null hypothesis and conclude that there is a significant mean difference in fruit weight across the fertilizer type. Then the last bit is the interaction. This is 0.03. Again, it is less than this. So we say that there is a significant difference across the fruit weight in the interaction between watering frequency and fertilizer type. So that's how you compute or you do our analysis. So another thing that maybe I would like us to see visually, we have something known as interaction plots. So we can try to draw an interaction plot here and just see how did this thing perform all through. So if I get it that way, and just copy this, I'll just do a simple analysis here. So I'm just interested in the average values. So you delete all the other thing and then I remain with the average values only. So I want us to plot uh, plot great. So what we need to do again, I want to pick these variable names here. Then I put them here. So we have you put this all these. Good. So that's how our data had been arranged. So I just put them here. So now great. Now these are the mean values for the interaction. So if I have the mean values for the interaction and I decide to plot these, once I decide to plot this, go to insert. Then I need I'll be using the line which tends to show us the best. So if I take this plot here, now just look at it. You'll find that thrice a week across all the types of fertilizer, thrice a week watering, thrice a week will tend to lead to a higher weight. So you can see graphically that this is the highest weight that we are going to get when you adopt thrice a week. You're going to get the highest weight, no matter what type of fertilizer that you are going to use. So that is one of the things that it was trying to tell us. And then when you go to calcium, we can even decide to change our rows here, and then you go to this. So you'll find that look at potassium. Potassium here at the start, it is like almost all of them are like recording the highs. But you can see this potassium is in yellow. So if you go all through, you'll find that even thrice a week potassium, at twice a week potassium was still high, at thrice a week potassium was still high, and only at daily at week daily watering daily is where that it didn't record the highs, but also when you didn't apply any water it recorded the highs. So it can tell you that potassium is one of the best fertilizer to apply for you to get high weight. So and you can see here potassium and thrice a week were the highest. So it tells you that the best interaction for all these is phosphorus, is potassium and thrice a week. However, we tend to have other post hoc analysis that can try and give us